Benzene is a very harmful material and it is a known carcinogen. That is, it causes cancer, and you would never be able to handle it in a school or college laboratory. You may then wonder why we learn so much about the chemistry of this compound. Although benzene itself is harmful, many of its derivatives are not, and as already mentioned, substituted benzenes are used extensively in medicines, dyes, pesticides and foodstuffs, and also occur naturally in some amino acids. Therefore, adding groups onto a benzene ring has always been of interest to chemists, as the resulting compounds may be useful. In the early days of synthetic chemistry, it was always very hard to replace one of the hydrogens in a benzene ring with an alkyl chain to make a substituted benzene. However, in the late 1800s, a French chemist, Charles Friedel, and an American chemist, James Crafts, developed an electrophilic substitution reaction for adding on alkyl groups onto a benzene ring. This is referred to as a Friedel-Crafts reaction. The mechanism is similar to the halogenation of benzene with a halogen carrier and the nitration of benzene using NO2+ ion that we have previously covered. We will look at this example where we add an ethyl group onto a benzene ring. We need to start with a halogenated ethane like chloroethane and a halogen carrier like aluminium chloride, although iron 3 chloride could also be used. This will produce a reactive carbocation which is an electrophile and can attack the benzene ring. A pair of electrons from the benzene ring are attracted towards the positively charged carbocation, creating an intermediate with a positive charge within the ring. A pair of electrons making the carbon to hydrogen bond move to restore the ring, and at the same time a bond is formed between one of the chlorines from the AlCl4- ion and the hydrogen. Hydrogen chloride results as one of the products along with the substituted benzene, in this case ethyl benzene. The halogen carrier catalyst is regenerated. Alkyl groups are electron donating, which means they push electrons into the benzene ring, making the ring more attractive to electrophiles. Therefore, once a ring has been substituted in this way with an alkyl group, it more readily undergoes further alkyl substitution. Further substitutions can be minimized by having an excess of benzene, which reduces the probability of the reactive carbocation coming into contact with an already substituted benzene molecule. The different substituted compounds can be separated by fractional distillation. Alternatively, an acyl chloride like ethanol chloride can be used in Friedel-Crafts reactions in place of the haloalkane. The resulting ketone group on the benzene ring is electron withdrawing rather than electron donating, and will pull negative charge from the benzene ring and make the ring less susceptible to electrophilic attack, and consequently only produce a singly substituted product.